Hey everybody, Ms. Dietrich here. I want to compare and contrast two formulas that you may see that help you to find the surface area of a square pyramid. And you may have seen this one that I have written here in blue. Surface area equals the side squared, so that you take the square, whatever the side of the square is, and you square it. And then you add to that the four different triangles that you have, which would each be the same size. But I want to explain how can this formula work? If this is the formula for it, how do we possibly say this is too? Well, I want to show you, and I'm going to use these triangles that I have here to help you understand it. So if we take these triangles and just move them over here for a second, so I'm going to move that one over here, and what I'm going to do is I'm just going to rotate this to show you something about this. If you take two of the triangles, I'm going to make two parallelograms. So I made one with that, and how about I rotate this just to make it look a little more similar to the one we were looking at. So we have this one, and let me just rotate this so that slides in nicely to form the parallelogram. All right, so now if you look at this formula, see how we're talking about we have two of something? And what are the somethings? They're two parallelograms. Two parallelograms is the same thing as four triangles, because isn't this 1, 2, 3, 4 triangles? So we can think of it that way. But because this is a more what I call user-friendly formula, then let's use this one. So we still have to find the area of the square, right? This piece right here. And in the formulas that you'll see, that's represented here. And in this formula, it's represented right here. So let's just kind of compare and contrast the two formulas. So if we proceed with the blue formula, right, and we plug in the numbers and substitute them in, the side they're saying is 12. And we would have to square that. Now, if we use this formula, that's the same thing here. We would square that. All right, so now let's talk about the triangles. Now, if they're telling you that this is, if we know that that's 12, right, because they're all 12. They're all 12. All the sides are 12. That's going to be the same thing as the base of each of the parallelograms, wouldn't it be? The base of each of the parallelograms would be 12. So let's plug that in to this formula. We have two parallelograms that each have a base of 12, and the height would be 7. Now let's make sure we understand that that would also be the height of the parallelogram. Let me pull that over here so you can see. See, that's the height of each of the parallelograms, 7. Now, does it matter what order you do that in? No, not really. But we basically have to multiply 2 times 12 times 7. So in any order. So let's just put it in as 7 times 12. All right, now, if it was me doing this, I would take advantage of the fact that you can do 2 times 7 in your head. You can also do 2 times 12 in your head. So whichever way works better for you. But if we do 2 times 7, we're going to get 14. And we have to find what 14 times 12 is. And then we have to also know that 12 squared would end up being 144. It's the same thing as 12 times 12. Now, if we did that in this formula, we'd still get 144. All right, so now let's take out our trusty calculators here. And if we finish up the formula that I have on the left, we're multiplying these two numbers together, 14 times 12. And we're getting this number, 168. So surface area is going to equal 168. That's the area of all four of the triangles, by the way, plus the square base. Now, let's compare and contrast that to doing it this method. Now, if we do it this method and we say to ourselves, well, we're going to find the area of one of these triangles. So if we find the area of one of the triangles, we know that the base is 12, and we know we have 4 of them, by the way. And if we substitute that into the formula, the base is 12, and the height of the triangle, they're telling you right here, is 7. All right, so we can multiply this in any order that we want, but let's say we're going to focus on finding the area of one of the triangles first. We might do half of 12 is 6, multiply the 6 times 7, and get the 42. and realize that we have 4 triangles that each have an area of 42. So let's bring everything down. Surface area equals 144 plus 4 times 42. Now, if I multiply 4 times 42, let's look at that on the calculator, then we're back to this number that we had over here, which is 168. So we're adding 144 plus the product of these two numbers, which is 168. Now, in either situation, we have to add the 168, which is the area of the square, plus, or I'm sorry, this is the area of the 4 triangles, plus the area of the square. So let's see, this is the same numbers that we're dealing with over here. So let's take out our trusty calculators. 168 plus 144. And we end up getting 312 square, and I'm forgetting what it was, so I got to look it back up. Inches, square inches. So we get that either way. Now, if you compare and contrast the different approaches that we can take to find this, isn't the one on the left, we have 1, 2, 3, 4, 5 lines of work, versus the one on the right, if we count how many lines of work we have here, we have 1, 2, 3, 4, 5, 6 lines of work. So we save a whole line of work by just using this more simplified formula. Now, keep in mind that commutative property says that these terms can be reversed. So if you want to put this number first and then this number after, then it might look a little more similar to the one that we have over here. Now, this one is a little bit easier for your brain to process because it helps you to understand the different faces. So we have our square base and we have our 4 triangles. So if that helps you to use this formula just because it makes more sense in your brain, then this is a perfectly acceptable formula to use. But if you are like me and you like the idea of, hey, I like more user-friendly things, then you can use this formula. And again, this will not work for a triangular pyramid. This is for square pyramids only. So that base has to be a perfect square. If it's a rectangle, then this is a no-go. Don't use this formula. If you're talking about a rectangular pyramid, it has to be a square pyramid, which means that all the lines around that base are equal and congruent.